So here are the answers to the questions at the end of the previous chapter. Hopefully you've got all these right. So why don't you tick these off before we go on to hydrocarbons as fuels. Now a fuel is something that we burn to release energy. Now this is known as an exothermic reaction. Exo means give out, and thermic means heat or energy. So it's an exothermic reaction. Burning fuels. Now if plenty of oxygen is present, fuels will burn completely, and this is called complete combustion. But if insufficient oxygen is present for this, for example if the air inlet pipe is blocked, then fuels will not burn completely, and this is called partial combustion. You may get some different products. Now, complete and partial combustion both produce waste products which relate to the elements present in both the fuel and in the air. For example, if impurities are present in the fuel, such as sulfur, then they will also burn to produce waste products. And what about in the air? Well, nitrogen is present as 80% of the air, and it does burn at very high temperatures, for example those found in a car engine, and in this case it will produce nitrogen oxides. So what are the waste products? Well, for complete combustion the waste products are carbon dioxide, that comes from the oxidation of the carbon in the hydrocarbons in fuel. Sulfur dioxide, that comes from the oxidation of sulfur present as an impurity. Water vapour, that comes from the oxidation of the hydrogen present in the hydrocarbons in the fuel. Oxides of nitrogen, as I just explained, and particulates, this is specks, soot and unburnt fuel. Partial combustion, well, we have all of the same products as above, but if there's insufficient oxygen for full complete combustion, then we may get some carbon monoxide produced as well as carbon dioxide. Now, acid rain can result from the combustion of fossil fuels because when sulfur dioxide and oxides of nitrogen, which are formed by combustion of fuels, dissolve in rainwater, they form acid rain, and this can damage plants, wildlife and buildings. Global warming can also be a consequence of burning fossil fuels because the CO2 and the water vapour from fuel combustion contribute to what's called the greenhouse effect. They act as insulating layers around the Earth, leading to global warming. And have you heard of global dimming? This is caused by particulates, little specks of dust and soot and unburnt fuel from the combustion of fuels are released into the atmosphere, and they reflect light back into space, and so this is causing global dimming. Now it is possible to remove impurities from fuels. You can remove impurities such as sulfur from fuels before they're actually burnt, which means that you're reducing the amount of sulfur dioxide that's produced in the waste gases. Sulfur dioxide can also be removed from the gases produced at the end of combustion. So for example, the waste gases produced by power stations can be scrubbed so that sulfur dioxide can be removed. So it can be removed either before combustion or after. So what about if we replace fossil fuels with some biofuels then? Let's have a look at biofuels. So starting out with biogas, this is methane that's generated from decomposing plant and animal waste. Now the advantage of this over crude oil is that it uses waste products, so it's not using up a precious finite resource. And it's renewable, which means that we've got a fairly limitless supply of it. Disadvantage is though that it still produces CO2 when it's burnt. Biodiesel is made from plant oils, and we can also recycle used cooking oil to turn it into biodiesel. Now the advantage of this is that it's carbon neutral because the plants take in CO2 in photosynthesis, and the CO2 is then released when they're burnt. It's less toxic to the environment than crude oil, and it burns cleanly because there aren't any impurities in it like sulfur, and that also is renewable. Ethanol is made from fermented sugarcane, and that also is carbon neutral because it comes from plant material. It also burns cleanly and it's also renewable. Now, both of these biofuels do have their disadvantages. They both use large areas of potentially food producing farmland. So we're using farmland to produce fuels instead of feeding the world's population. They both cause vast tracts of natural habitat to be destroyed, and biodiesel doesn't work perfectly at very high or very low temperatures, so it's not as effective as diesel if the weather is very hot or very cold. And also beware, this term carbon neutral, it's not strictly true, because although all these crops take in CO2 in photosynthesis, nevertheless they do use fossil fuels in production, in the machinery, the agricultural machinery that's used to process them and to transport them. So carbon neutral is not strictly true. We're looking at hydrogen as a potential fuel in the future. Now, the advantages of hydrogen are that it burns cleanly. Only water is produced as the waste product. There's no carbon involved, so there's no CO2 being produced. Disadvantage is that the hydrogen is produced by the electrolysis of water, which makes it an expensive process. The gas itself takes up a large volume, and of course hydrogen gas is explosive and there is danger present. There's a risk of leaks. Okay, so quickly test yourself. Hopefully you've printed out all these notes so you can answer it now and find the answers at the beginning of the next chapter.